Nginiphethelena ngo question 5 for this lesson. This question is focused on work energy and power. Check out the description box for more questions engwaphendulile for the September 2022 KZN question paper. So question 5. Actually the question lena man. The question lena inenkani, igcwele inkani nje. Uzoba ukuthi ngichaza ukuthini. This question 5, it's a two-part question. Kuno 5.1, we're seeing a truck on an incline. Then sibuye sibe no 5.2, where we have two cars alandelana emuva, right? So, asicale ngalo 5.1, a truck of mass 1,000 kilogram moving down a rough, but he moved down a rough incline track, has a speed of 0.8 meters per second at point P. Point P is 1.8 meters above the ground level. Above the ground level, QR. Okay, now ground level here to QR. The length of QP is 2.2. Where's QP? The length of QP. Okay, QP now. It's this length. It's the length of the incline. When the truck reaches point Q, it has a speed of, right? Okay, so it's not 2 years speed la. Lagu Q as well as gubani gu P, right? Bese basiphana distance for iso travel ile truck from P to Q on the incline. Lagu 5.1.1 kwamele si state the principle of conservation of mechanical energy. Eish, the question in inkani. Aye, definition. Total mechanical energy of an isolated system, system remains constant. Uzoyibona the question lena ishinenkani man, igcwele inkani man. Yes. Okay. Babuza ke la. Is mechanical energy conserved as the truck moves from point P to point Q? Yes or no? The answer is no. Total mechanical energy of an isolated system remains constant. This system is not isolated. There are external forces affect the motion of the truck. There's frictional force, maybe it's a rough inclined track. There's a frictional force. Once there's a frictional force or an applied force, just know that mechanical energy is conserved. Bayabuya ke manje, but alright, use ulaku 5.1.3. Hey, stubbornness biyaqala ke manje. Use energy principles to calculate the frictional force acting on the truck as it moves from point P to point Q. Use energy principles. So you can use your work energy theorem. Since there's a non-conservative force, a frictional force, you can also use the non-conservative work done by our non-conservative forces, right? So there's two formulas. Like work energy and power. Now, but to use energy principles, you can either use the two, work energy theorem or the one yama non-conservative forces. On most of the videos for this channel, only work energy and power, I've only focused on formula A1, which is the work energy theorem. So this time around, I would like to use this one. Work done by our non-conservative forces is equal to the change in potential energy plus the change in kinetic energy. So Aspani said this one, right? There's only one conservative force, which is what? Work done by a frictional force, equal to open bracket, m g h at q minus m g h at p. Right, that's just now 2 yama points la. So it's final minus initial. Final q minus initial ubani ulokanji u p. Open another bracket plus open another bracket. Just calculate the change in, what's this? The change in the change in kinetic energy squared the velocity at q minus 1 over 2 mv p squared. Work done by a frictional force is equal to, then we substitute again. I think 7 say different pen. Yes, so lana ya substitute. What is the mass? In mass here too. For the track it's 1200. Vala 9,8. HQ it's 1,8 at Q. Wait, at Q it's 0. Alright. So lagu Q, I height here to go about 0, meaning that I potential energy go about 0 minus. So you have vulelinya brackets it 1200 9,8, and then the height at P it's 1,8. Valalo bracket. I think 7 say a red pen. Let's go back to purple plus vulalo bracket purple. Then lana it's half 1200 vala, and then the velocity at Q was 4. Yeah, substitute it squared minus 1 over 2. What is the mass? 1200. What is the velocity at P? It was 0,8 squared. Valalo bracket. Then we calculate again. Remember. Ngifuna calculator ini the frictional force. But is 7 to calculate the frictional force acting on the track. I cannot find the frictional force without the work done by a frictional force. So that's why I'm calculating the work done by a frictional force so that we can find the frictional force here. Okay. So lana it's 0. So give about minus 1200 times 9,8 times 1,8 plus vuli bracket guba half multiplied by 1200 multiplied by 4 squared minus a half times 1200 times 0,8 squared. Valalo bracket. Answer 9. Answer yethu bani negative 119.52 joules. So this is the work done by a frictional force. Now sifuna a frictional force angithi. So we know that the work is calculated as using the formula le F frictional force times delta. Okay, it's cos x. No, it's right. So delta x times cos theta is equal to minus 119.52. Right, 52. Then F it's unknown. What is the distance again? The distance with delta x is the distance traveled by the truck from P to Q. Ubani basipay na 2.2. 2,2 multiplied by cos, what is theta? With theta uyoba equal to 180 degrees. Ngoba le truck na slide or na move down the incline, the frictional force it's acting in the opposite direction. The angle is 180 degrees equal to minus 119.52. Then siyaqhubeka ke manje size ngapha. So kuyoba F times nang multiplier la I should get negative 2 comma 2 equal to minus 11952. Divide both sides by minus 2.2 minus 2.2. So f is equal to divided by negative 2 comma 2. Answer 5432 comma 7222222. Let me be sure, or 73. Now you round off to 2 decimal places, you go 73 newtons up. Right? Now I answer you together. This is the frictional force experienced by the truck. Now slide it down the incline. Oh yeah. Nkani 1 defeated. 5.2. So I go to the second part again, manje. Now, the second part of the question, it's a different story, man. It says Pumela go incline. It says Lana, man. We have 2 drivers or 2 cars. Our driver is Motozab. Okay, so the driver of a 1,000 kilogram car traveling on a highway at 35 meters per second applies brakes to avoid hitting a van in front of him, which had come to rest because of traffic ahead. After the brakes are applied, the constant frictional force of 8,000 newtons acts on the car. So wakhuluma at this one. This is a van, right? This is a van. Okay. As more negative, state the work energy theorem in words. Alright, you should know this stuff. The work done on an object. The work done on an object. These are laws, or on an object. These are laws or principles of conservation of mechanical energy, conservation of momentum, Newton's second law, Newton's first law, Leclerc's principle, work energy theorem. Komele ukwazi ukwadefine ngoba ama laws abathanda ukwabuza, and it's also free marks. I mean, work done on an object by a resultant force by a, let's say, net force is equal to the change in an object, to the change in the object's kinetic energy, in the object's kinetic energy, and the object's kinetic energy. So this is our work energy theorem. Bese lana nayo nyinkani futhi, nayo nyinkani la, inkani yodwa le. Use energy principles again. Determine the minimum distance required for the brakes of the car to be applied to avoid a collision with the van. To avoid a collision with the van. Alright. So lana, we can either use like this one, or alright. Also on the first part of the question, say non-conservative forces. We also have non-conservative forces la, but hey, their method man in driver crazy. So I'll just use what's this man? The work energy theorem. So Sizoti W net work done is equal to the change in kinetic energy of the car, right? So lana bafuna the minimum distance required, right, for the brakes of the car to be applied to avoid a collision with the van. Now check this out. The final velocity, it must be what? Must be 0 la. Yes, the final velocity must be 0. So therefore work net, how many forces do we have la? Sine frictional force, check. Sibuye sibe ne gravitational force, check. Sibuye sibe ne gravitational force la, check. FG. Sibuye sibe ne normal force, right? Check. Alright. Now the net work done, it's the sum of the work done by each of the individual forces. It's another way you calculate, or ngavela calculate ubani F net for this car. Mina ngizoyenza so CT work done by frictional force, work done by gravitational force, plus work done by the normal force is equal to 1/2 m v final squared minus 1/2 mv initial squared. So the work done by frictional force now, it's 8,000. It's F times delta x times cos theta. So give out delta x la, which is unknown, it's the values for we calculate la, times cos theta. What is theta? 180 degrees. Remember, the direction of motion is forward, but the friction is in the opposite direction. So the angle between the direction and E force to the frictional force, it's 180 degrees plus 0 degrees. Not 0 degrees, but 0 work done. A gravitational force, the gravitational force, it's acting down. The direction of motion, it's to the right. So lama force is anjani, the gravitational force, it's acting perpendicularly to the direction of motion. So any force that's acting at a 90 degree angle, right, or even perpendicular to its direction, does 0 work. Plus, as well as in normal force, now it's perpendicular to its direction of motion, so it's 0 work done, equal to, King 7 said different pen gemanj, equal to 1/2. Alright, for the final velocity, for the final kinetic energy kuyoba 0 ngoba i-final velocity ngifuna ukuthi iba ubani, iba 0. I want to see the car stop. Ngifuna ukwazi ukuthi i-distance, ngifuna the minimum distance required for the brakes of the car to be applied before i-collision. So ngifuna ukuthi imoto yami ibe 0 i-final velocity yakhona when it applies in ama-brakes. Hence I'm putting 0 la ngoba i-velocity nangabe 0, i-kinetic energy yethu nayo izoba 0. Minus 1/2, what is the mass? 1000. Velocity, initial velocity ubani 35. So lana kuyoba 35 squared, right? So I think we'll back to red. So lana kuyoba negative 8,000 change in x is equal to lo negative ngimthatha ngoba cos 180 degrees, it's a -1. -1 times lo 8,000 is total -8,000 plus 0 plus 0 sithola this one. Then ngapha kuba minus -1/2 times 1,000 multiplied by 35 squared. Ithola -612,500. 612,500. Divide both sides by minus 8,000 minus 8,000. Cancel. Delta x is equal to, divided by -8,000 is equal to 76,56 meters. So this is the distance akwamele ayenzani apply ama brakes key. Use any to Okay, so nangabe reach a distance engaka, if the delta x, the distance between the two cars, kumele apply ini ama brakes so that nangabe uyaphambili angakhona ukucollide nani nale van. Right, nkani number 2 defeated. Sicedile ke la. Now let's go to 5,23. So la ku 5,23, what do we have? Again, use energy principles to determine the speed at which the vehicles would collide if the driver had applied the brakes when his car was 30 meters behind the van. So sifuna ukuthola the final velocity, right? Again, net work done ngisebenzisa work energy theorem. Yes, friction plus G plus normal force is equal to 1/2 mv final squared minus 1/2 mv initial squared. So lana it's 0 0, just like on the previous question. Lana siyoba no 8,000. Now the distance delta x sekawubani sekawu-30 ke manje, times cos 180 degrees is equal to 1/2 mass 1,000, final velocity unknown, ngifuna yona la. So vf final, vf squared minus 1/2 m, it's 1,000, v initial it was 35. Eish, nkani yodwa le, yabona. So sengisubstitute, I calculate le question yerre, Jesus, kancane energy principle, kancane energy babhora labantu laba. Okay, let's calculate this part. 1/2 times 35 equal to, so okay, so like about 500 la, half times 1,000 squared minus 612,500. Is it okay? So lana ke ba ubani hayi madoda, le question suka madoda man. Hey no minus 240,000 transpose minus 240, 123 plus 612, 500 is equal to 500. Yes. Why vele? Why msebenzi ongaka? No ne load shedding up. Yes. Okay, all right, okay. So now 372,500 is equal to 500 squared. So divide by 500, divide by 500. Yo nini calculate abasathi discuss enyana nje, bona bathi solve man, solver. 745 is equal to vf squared, square up both sides, v final is equal to square root of an answer, it's 27,29 meters per second. Nangabe ubukele le video waze wafika la, azishayela izandla, nami ngizishayela izandla. Zingafika la uloku ngibhizi ngiyacalculate ama energy principle, no man, no. Bangabuyenza ama question kutabhore so man. 5.1.2, how would the speed calculated in 5.2.3 change if it was raining during the incident. Choose from increase, decrease, or remain the same. Give a reason for the answer. So lana uma ngabe u-K53 umenzile or unayo i-learner's license, banokuthi during rainy conditions kanje, uma u-driver, you need to keep a safe distance from the car ahead of you. Bangisho ngoba when it rains ngathini kuzokuthatha isikhathi ukuthi uwenze imoto yakho ukuthi yenzeni i-brake, uyabona, ngoba indlela or the road becomes more slippery, uyabona. So if ever basibuza ukuthi le speed esilapha ku 5.2.3 during if it was raining during the incident, kuzokwenzekani ngale speed? Sizo increase as decrease or si remain the same? Sizo increase the speed less. It will increase because of the road surface izoba na less friction, so le moto izohamba much more faster. So yabona, so it's because the road would have less friction. Because of the road would have less friction, less frictional force needed for the braking. Needed for braking, not to go pull but braking the car. Braking or applying brakes for the car. Applying brakes for the car. Needed for applying brakes for the car. Yeah, something like that. Something like that. I hope you enjoy this video. Mina sengiphethe inhloko manje. Check out the description box for more recordings for this question paper, as well as a link to another YouTube channel engicreatile for ama lessons only. So ungakhohlwa ukulike, ukushare nokusubscribe. For now guys, asibonane on the flip side. Ngiyolala manje. Bye bye.